All right, here are quiz 5 solutions for Math 111. So we're given three functions here, and we want to compose some and find inverses and do that kind of stuff. So function composition, the first one says find and simplify g of f of x. Kind of nice that it was already written in the handy notation. The way I figure out what g of f of x is I replace the innermost function f of x with what f of x is. F of x in this case is 1 over x. And then I can evaluate that. I know what g of x is, so to figure out what g of 1 over x is, I look up here at g of x, and I replace all the x's with 1 over x is, which gives me something like that. But it didn't just say find this thing, it said simplify this. So the way we simplify is we first want to change this into just a fraction over a fraction. Really a rational expression over a rational expression. We need a common denominator. If you think about this as 3 over 1, we can write the top like this and the bottom like this. So really this is 3 over 1, so I multiplied by x over x here because that's just 1. And this is 2 over 1, so I multiplied by x over x because that's just 1. And the reason I did all that is because now I have the same denominator here. And I have the same denominator here. And the way you multiply or you divide fractions is a lot like multiplying them, but you multiply by the reciprocal. So I get to here, and I can cancel out the x's and get my final answer is 3x minus 1 over 2x plus 1. All right, to figure out the domain, what I need to do is I need to find domain of, first of all, the inside function, f of x. And then the composite function, 3x minus 1 over 2x plus 1. So I'll figure both of these out separately. Over here it's easy. I can't divide by 0, so x can't be 0. Over here I can't divide by 0, so 2x plus 1 can't be 0. In other words, x cannot be negative 1/2. Let me show that. 2x can't be negative 1, so x can't be negative 1/2. So the domain of g of f of x is everything except for 0 and negative 1/2. If it helps, you can draw a little number line. Got 0 somewhere, negative 1/2 somewhere. And I want everything except for those 2 points. So I got 3 different intervals in my domain. My domain is everything from negative infinity to better infinity, all the way up to negative 1/2, but not including negative 1/2. Union negative 1/2 up to 0. Again, not including negative 1/2 nor 0. And then everything bigger than 0. So that's my final answer. Lastly, is h of x 1 to 1? Okay, so first of all, what was h of x? Maybe I'll write it down here. X squared minus 10x plus 15. Is it 1 to 1? It is not 1 to 1. You can argue that several different ways, but the basic idea is because this is a standard parabola with kind of some shifts going on. So if you picture the graph of that, it wouldn't pass the horizontal line test. So this is not 1 to 1 because it would not pass the horizontal line test. The graph of this, maybe I won't even draw axes, looks something like this, and I can draw this horizontal line here that intersects it twice. So it's not 1 to 1, but I can make it 1 to 1 if I restrict its domain. To figure out what I should restrict its domain to, I have to complete the square. So completing the square, I get x minus 5 squared minus 25. Maybe I should, sure, I can put them here. Put these little blinders on here. And so what I'm doing is, all right, leave this plus 15, and then x squared minus 10x is the same as x minus 5 squared minus 25. Half of this number goes here, this number squared goes there. And then those blinders aren't doing anything for me, so I can rewrite the equation just like this. And so what this looks like, this is a parabola that was shifted to the right by 5. Right? If you think about what this parabola looks like, I started out with this graph, and then I went down 10 and right 5. So down 10, right 5. I don't know, there's 5 and there's 10. So what I get is that the vertex of this parabola is now here. Roughly speaking, my graph looks something like this. So in order to restrict its domain to make it 1-to-1, I don't like this problem. Well, whatever, I'm this far. In order to restrict its domain to 1-to-1, what I need to do is restrict domain to everything from 5 up to infinity. Because what that will do is it'll get rid of everything to the left of this point and just give me sort of this graph in red, which is 1-to-1. Okay, so once I've restricted its domain to that, then I can find the inverse function. The way I figure out the inverse function is you could start with y equals x minus 5 squared minus 10. Solve this equation for y, for x, sorry. So add 10 to both sides, then take the square root of both sides. Normally when you take the square root of both sides, you have to put in a plus or minus over here, but since we restricted the domain to just the positive side of this graph, we don't need a plus or minus here, it's just a positive. So finally, what we get is x equals, if I add 5 to both sides, 5 plus the square root of y plus 10. Kind of ran out of room there. Let me try again. X equals 5 plus the square root of y plus 10. And so this will be my inverse function. You want to have x as the input for your function. So what I have to do is change the y into an x and say 5 plus, I'm going to run out of room again, 5 plus the square root of x plus 10 is the inverse of this function right here if it's restricted to this domain. Whew, all right, and that's the end of this problem.